Good morning, students. Today we will discuss error analysis, and in error analysis, we will first discuss accuracy and precision of instruments. Accuracy and precision of instruments. Accuracy and precision of instrument. What is accuracy and what is precision? So about accuracy and precision, first of all I want to explain you that there are two terms, that is accuracy and precision, often used as interchangeably. Means we can interchange both the words accuracy and precision. They have a special meaning. And what is the meaning of accuracy and what is the meaning of precision? Accuracy means to say that accuracy means to say that how close the measured value is to the true value of the quantity. Closeness of measured value to the true value of the quantity. True value of the quantity means to say that suppose you had measured the value of length of a given object as 3.568. That length you had measured, and you are knowing the length of that object as 3.568, but you have given with three measured value. You had given with three measured value. First measured value is 3.5 centimeter. Second value is 3.56 centimeter. And the third value is 3.0 centimeter. And then it had been asked with you which value is much closer to the measured value, this measured value. Obviously you will say that 3.56 is much closer to our measured value, that is 3.568. so this is the accurate value, or this is the accuracy. This is the accuracy, means the instrument by which you had measured this value has greater accuracy as compared to these two values. So this is the meaning of accuracy. Now precision. Second thing is precision. 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 Precision is nothing. It is the resolution or limit of the quantity to be measured. It is the resolution or limit of the quantity to be measured. Now for example, suppose the true value of a given object is 3.568 centimeter. This is the true value of the given instrument. This is the true value of the given instrument. And we had measured or the three instruments has measured its length. First one had measured its length as 3.5 centimeter. Now, whatever the instrument you had used to measure the value, to measure the length of the given object, 3.568 centimeter, that is 3.5 centimeter. It gives the measurement only 3.5 centimeter up to 1/10th part of the decimal. 1/10th part of the decimal. It means to say that the resolution of the instrument is 0.1 centimeter. The limit of resolution of that instrument is 0.1 centimeter. Means, what is the limit of resolution? Suppose we have taken a meter scale. This is 0, this is 1, this is 2, this is 3. So 3 centimeter complete, and after 3, between 3 and 4, there are only 10 divisions. There are only 10 divisions. So this will give 3.0.1, 0.2, 0.3, 0.5. There are means one big division is divided into 10 divisions. So its resolution is 0.1 centimeter. Again, second thing is, you had taken another instrument, and that instrument measures its value is as 3.56 centimeter. Means up to 100th decimal places, up to here, up to 10th decimal places, here up to 100. Means one big division is divided into 100 division, 100 small divisions, 100 small divisions, 100 small divisions. So its limit of resolution is 1/10 of centimeter. Its limit of resolution is 1/100 of the centimeter. And the third instrument, which measures 3.568 centimeter, means 1/1000, 1/1000 of the centimeter. Now it had been asked that which instrument is more precise, which instrument is more resolved, which instrument has more limit of resolution. So obviously you will tell that the third instrument, which is measuring the value of the given length as 3.568 centimeter, is much resolved, or its limit of resolution is greater. So more precise instrument is 3.568 centimeter. Clear? So this is the difference between accuracy and precision. I hope that both the terms accuracy and precision of the instrument is clear to you. Now we will further discuss about error in measurement. Now we will discuss about error in measurement. What is error in measurement? Error in measurement. Error in measurement. Error in measurement. Now, measuring process, any measuring process is the comparison of the given value with standard This is the measuring process. What does it mean? Measuring process is the comparison of measuring process is the comparison of the given value with the standard value. I had discussed while we are dealing with unit topic also, unit and measurement also, I had discussed what is the meaning of a standard value, and here also I am going to discuss. It means that suppose you are going to purchase 5 kilogram of sugar in grocery shop, and the shopkeeper does what? He had an standard measuring quantity, and that amount what you had told to the shopkeeper, he compares that amount with his standard measured value, and when the comparison is okay, then he gives you that quantity of thing what you had asked. So any measurement process, suppose you have to measure the length of your desk, then what you do, you used to put the meter scale on the desk and then compare that length with the standard length, and after that you used to say that this is that much, the length of the desk is that much meter on the meter scale. So the measuring process is nothing. Measuring process is the comparison of a given value with the standard value. No measurement is perfect because no one is perfect. No one is perfect. No one is perfect. How hard you will try to get perfect value, but there is certain amount of error. So no measurement is perfect and error is involved in the process. We can't remove error is involved in the process, and we can't remove that error. We can't remove that error. So what error is going to arise in our measurement process or in our measuring process, that error must be removed, that error must be minimized, and the minimization or removal of error is possible only when we have the idea about the error, how the error comes. So knowledge of error is very much important to minimize the error. So what is the error in measurement? Error in measurement. Error in measurement is nothing. Error in measurement is nothing. It is only the difference between the true value and the measured value. Difference in the true value and the measured value. True value and the measured value of a quantity is called error. Is called error. What is the difference between true value and measured value? That is called error in measurement. Error in measurement. that is called error in measurement. So error is equal to true value minus measured true value minus measured value is error. That is the difference between true value and the measured value of the quantity is called error in measurement. Error is equal to true value minus measured value. So obviously we had seen what is error and how the error in the measurement can be determined. Now there is a question that, okay sir, what is the meaning of true value and what is the meaning of measured value, and how the true value can be found in the measurement? The true value can be found in measurement. Suppose I am taking an example to explain you about the true value. I am taking an example. After explaining you the true value, what is the meaning of true value, we will discuss different type of errors. What are the different type of errors? First of all, we will understand what is the meaning of true value. True value means what? Suppose I had taken five students I had taken selected from the class, and along with that 5 students we had visited a very peculiar place, a very attractive place, and all of the 5 students had seen a beautiful picture there. Now suppose principal madam had called you and asked that 5 students that what you had seen there when you had visited that place. So one student had told that picture is very much beautiful and this thing. All the 5 students had explained their views in their own way. Now ma'am was quite suspicious about the thing and he told you to draw the picture, that beautiful picture, and came to me or give to me, then I will analyze. So all that 5 students had drawn the picture according to themselves, what they had seen. Now madam had visited that place, and after seeing that object, he told that the picture of student number 3 is quite close to the true picture, or you can say that K means that what the student third had drawn the picture is quite close to the actual picture, or the picture which is drawn by that student is for the true value. For the true value, what you will do? For the true value, whatever the observations you had seen, you had to take the average of all the observations. And on taking the average of all the observations, whatever the value you will get, that value is the close to the true value. And that average value which you had observed, by taking the mean of these, the difference of this close true value with these values gives the error in the first measurement, second measurement, third measurement, and fourth measurement. I hope you all had clarified, or you all had understood that what is error, what is true value, and how can you guess the true value. So this is the true value, means whatever the measured quantity. Suppose you had measured the length of an object, and one student has measured, again I am explaining it, one student has, first student had measured the value as 3.56 centimeter, second student has measured as 3.5 centimeter, third student has measured as 3.6 centimeter, fourth student has measured 3.67 centimeter. Now for getting the true value, you have to take the average of 3.56 centimeter plus 3.5 centimeter plus 3.6 centimeter plus 3.67 centimeter divided by 4, and whatever the value you are getting, that value, whatever the value you had got, that value is the true value, and the difference of this value from first value, difference of this value from second value, third value, is error in all the measured quantities. So this is the true value. Average of all the measured value is the true value. Now there are two types of errors generally occurs. Generally the errors is further classified into two categories. Error is further classified into two. All of you had understood about the true value and the measured value. Now error can be classified in two categories. First one is systematic error. And second one is a random error. First one is systematic error and second one is random error. Now one by one we will understand what is systematic error and what is random error. So first of all we will discuss about systematic error. First one is systematic error. As clear from the name, systematic error means that type of error in the measurement which comes due to the system. Error which comes in the measurement due to the system involved. That error is called as systematic error. Now there is a question in your mind, what is the system involved in the measurement? So think over that. What is the system involved in the measurement? The system involved in the measurement is your measuring instrument, your way to perform the experiment, your calibration of the instrument, how the measurement you are taking. These are the various systems which are involved in your measurement, and if there is any imperfection or malfunctioning of any part of the system which is going to be involved in the measurement, then the error which comes in the measured value is called as systematic error. So systematic error can be defined as those errors that tend to be in one direction. Those errors which tend to be in one direction, either positive negative, either positive or negative, is called systematic. Is called systematic. Either positive or negative is called as systematic error. Now, what is the meaning of saying that the error will tend to be one direction, either positive or negative? Means to say that, as in the previous discussion we had told that okay, the error which arises due to imperfection in system or our measuring techniques or performing experiment, due to these things whatever the error arises in the measurement is called as systematic error. Now, how can you correlate that thing with one direction, either positive or negative? It means to say that if system is malfunctioning or our observation technique is wrong or we are performing the experiment in a wrong way, due to that either you will shift on the left side of the true value or on the right side. Either the error is positive error or the negative error. Means, suppose the accurate value is 3 centimeter, but due to imperfection of our measuring technique, or you are getting the value 3.1 centimeter or 2.9 centimeter. So as you are moving, if you are getting the exact value 3 centimeter, there is no error, that is zero error. You are getting no error, so it is called as zero error. If you are moving towards 3.1 centimeter, means towards right of the exact value, then positive, zero error. And if you are moving due to imperfection, then negative, zero error. Negative, zero. So we are saying that which tend to be one direction, either you will move in this direction or you will move in this direction, either in this direction or in this direction. This means unidirectional, one directional, either positive or negative of the zero. So this error can be minimized by subtracting that value from the measured value, and this error can be minimized by adding this value to the measured value, and that error can be minimized. So this is the concept of one direction, either positive or negative, of the systematic error. Now we will discuss about some sources of the systematic error. What are the sources of the systematic error? Sources of systematic error. Sources of systematic error. Sources of systematic error. Sources of systematic. What are the sources of systematic error? First one is instrumental error. As it is clear from the name, instrumental error. Instrumental error. As it is clear from the name, the error due to the instrument, error due to the instrument, error due to instrument, and error due to instrument means to say that imperfect design, or manufacture or calibration of the measuring instrument. Suppose you will see in the laboratory about vernier caliper. In vernier caliper, sometimes it happens that the zero scale does not coincide. There are two scale, vernier scale and zero scale. So in vernier calipers, the zero of the vernier scale does not coincide with the main scale in certain instruments. Zero of vernier scale does not coincide with the zero of main scale. That is the instrumental error. Clear? The second source of systematic error is imperfection in experimental technique or procedure. Imperfection of experimental technique. Imperfection of experimental technique or procedure. Imperfection of experimental technique or procedure. It means to say that, okay, it is clear from the name, means you are not performing the experiment, or experimental technique is imperfect, or what procedure you have adopted for the measurement is the not appropriate procedure for the measurement. For example, write one thing. These errors arises due to experimental arrangement limitations. If there is a certain limitation in the experimental arrangement, then there is the chance of such type of error. Error, that is imperfection of experimental techniques. For example, you have to measure the temperature of human body. Then the appropriate method for measuring the temperature of the human body is putting the thermometer below the tongue. But someone is not putting the thermometer below the tongue. Someone is putting somewhere else, below the neck or anywhere else. They are going to put the thermometer for the measurement of the human temperature. Then obviously there is imperfection in the experimental technique and error will arise. Suppose you are weighing certain substance in any fluid, then there is a buoyant force against the weight of the object. If that buoyant force is ignored, then there is error in the measured value. So such things are called imperfection of experimental techniques or procedure. Now personal error. Third one is personal error. Personal error. Personal error is nothing. Personal error arises due to inexperience of observation, lack of proper setting of apparatus, and taking observation without observing proper precaution. Error due to the person taking observation, taking observation. The, the error which arises due to the person who is taking observation is its inexperience or how he is taking the observation. Suppose it is advisory in the measurement to take the observation from the normal point or from just above the point to be measured, but someone is taking or the reading from the left side or right side, then obviously there is error in the measurement. There is the error in measurement, and such type of error is called personal. All things are okay, experimental setup is okay, all things are okay, calibration is okay, and setting of apparatus is okay, all things are okay, but while taking the reading, taking the observation, the person is making error, so it is called as personal error. Error due to external cause. Error due to external cause. Error due to external cause. Various parameters such as temperature, pressure, volume, such as temperature, pressure, volume, etc. can affect our measurement. These are the external factors which affect our measurement. So these errors are due to, and obviously these are the causes of random errors also, which we will study in later topic. So these are what are the error due to external causes. These are the error due to external causes. Now, how the systematic error can be minimized? How the systematic error can be minimized? Minimization of systematic errors. Minimization of systematic errors. So this type of errors can be minimized by improved experimental techniques. Improved experimental techniques. Selecting better instruments. Better instruments. Removing personal error as far as possible. So this is all about the systematic error. Now in the next video we will discuss about random errors, list count errors, and then we will discuss absolute error, relative error, and percentage error. So that's all for today, students. Have a good day. Take care.